Welcome to my channel. I'm Zhang Jingxu. Let's look at the problem 17 in chapter 18. Chapter 18 is about kinetic energy of the gas. So there, first one, we need to find RMS speed of nitrogen molecules at 0 degree. So first one, keyword RMS speed, nitrogen, and 0 degree. So first one, we write the function to find the Rm speed 3kTm, right? Then we look at the inside. K is a constant. We can find it in our textbook there. T is a temperature. You can see it tells us 0 centigrade. We can convert it in unit Kelvin, so it becomes 273 Kelvin. The next one is the atomic mass for this molecule. It tells us it's a nitrogen molecule, so very easily we can find atomic mass for nitrogen is 32 U. There U is a mass unit, and it is just equal to this kilogram. Right? Now you can see you have K, T, and M. So input known quantity inside, you get answer there. The next one is determine how many times per second it would move back and forth across 5-meter long room on the average, and assume it made very few collisions. So what it means? Very few collisions. That means no energy change, right? So molecules moves from this way back and forth. No problems, very smoothly. The speed is just kept, it's constant, not changed. This will tell you very few collisions. Next one tell you the distance is 5 meters, but it moved back and forth. So the distance it moved become 2d. Do you agree? And then, how can we find how many times per second? So we need to find how many times per second. So that means we need to first find how much time it will take to make one run, right? To make one back and forth, and use 1 second divided by this time, we can get how many turns. Agree? So now first one we find the time for move back and forth. So for move back and forth, as we learned in previous, the molecules do the random motion in the room temperature, right? In this case, it can move x direction, y direction, and z direction. It's just for the region, for the space. So that means if we want to make it move in one direction back and forth, we just need to consider Vx, right? And we learned in previous this RMS speed, just consider the speed for x direction, y direction, and z direction. So we have this function. Do you agree? So we can write the V RMS square equal to Vx square plus Vy square plus Vz square, because these molecules do random motion in the x, y, z direction, so directions. Agree? And for each direction, they are same. So we can write it as 3Vx squared. Agree? Yes. So in this way, we can find Vx just as the speed in one direction. Vx equal to the Vrms over square 3, right? Now we can find the time for one back and forth. We can see the distance it traveled just 2d, and the speed is Vx. So we can input the Vx as the Vrms divided by square 3, right? And then can simplify it in this way. This is the time taken for one back and forth. Now, how many times per second? How many turns per second? So we use the total time 1 second divided by the time it lead to get how many turns it lead, right? N equal to 1 over t, and input the t inside, we get a function look like this one, and input known quantities d and RMS speed, we get answer there. Thank you.